Hello everyone. In this session, we will be doing orthogonal circles, which is something similar to what we have perpendicularity in straight lines, right? So let us start with orthogonal circles. Now we will have to define first. Say two circles, omega 1 and omega 2 are there, which are intersecting ones, and points of intersection I am naming as say A and B, correct? Now omega 1 and omega 2 are called orthogonal if tangents drawn at points of intersection, either A or B, are perpendicular, right? You can draw this picture, whatever I said. Two intersecting circles you draw and draw tangents at point of intersection, and those tangents should be perpendicular to each other. Then those two circles, what you have drawn, are orthogonal. Okay. Now, with this definition of orthogonality, we try to understand few more points. Any intersecting curves, not necessarily circles, would be called orthogonal here onwards if at points of intersection tangents drawn are perpendicular. Correct? Fine. Now let us move further. Next one is tangent to one curve is normal to the other curve at point of intersection. I hope this is clear to you. You can see that yourselves in the picture. And picture is something like this, that I have drawn two circles with C1 and C2 as the centers. I have named them as omega 1 and omega 2. Their point of intersection, one of them, of course, I have named as M. I have shown their radii also R1 and R2. Then what we are seeing in picture here is that tangent to omega 2 is normal to omega 1, and then that is nothing but that radius what I have shown as R1. And similarly, other way also you can see for R2. Okay. Now, if I say omega 1's equation is x square plus y square plus 2 g1x plus 2 f1y plus c1 equal to 0, and omega 2 as x square plus y square plus 2 g2x plus 2 f2y plus c2 equal to 0, and if they are orthogonal, then what next? Following statements, whatever we will be saying now, they all are equivalent. Means when you say these two circles are orthogonal, that is equivalent to what? When I say equivalent, that means one and the same. So if I say, for example, power of C1 with respect to omega 2 circle is R1 square. I repeat, I am saying power of C1 with respect to omega 2 means second circle is R1 square. Now saying this is as good as saying two circles are orthogonal. Similarly, power of C2 with respect to omega 1 circle is R2 square, or actually saying power of C1 with respect to omega 2 is same as power of C2 with respect to omega 1. These two statements are also equivalent to one another. Okay. Also, this all leads to one analytical condition. So, why I am writing this? Because from problem solving point of view, it is not only understanding. Certain things have to be worked out also. For working, what we will need is twice of G1, G2 plus F1, F2 equal to C1 plus C2. Now, wherever you get this kind of thing, that means those two circles are given to be orthogonal, whose centers are minus G1 comma minus F1 and minus G2 comma minus F2. I hope you are clear. All these four statements are equivalent. Two circles are orthogonal, or power of C1 with respect to omega 2, right? Power of C2 with respect to omega 1. One is R1 square, other is R2 square, and last one is twice of G1, G2 plus F1, F2 equal to C1 plus C2. These four statements are equivalent. From one, you can reach to other. Okay. So we take some standard results from whatever we have understood about orthogonal circles. If a circle omega with center C and radius R meets or cuts three circles omega 1, omega 2, omega 3 orthogonally, then C is the radical center of omega 1, omega 2 and omega 3. Recall what we have done in radical center. Now, how do we say so? This is one standard result which I am saying. Proof is not very big, but that would give more and more clarity in your understanding. Circle omega cuts circle omega 1 orthogonally means what? Power of C would be R square. Now, circle omega cuts circle omega 2 orthogonally means again here power of C would be R square. So I can straight away write one sentence. Power of C with respect to omega 1 and omega 2 is R square. And not only that, it is for omega 3 also. Okay. So C lies basically on radical axis of omega 1 and omega 2 because powers are equal. Correct. Similarly, I can say that C lies on radical axis of omega 2 and omega 3 also. So what must be C? C is nothing but radical center. So that is what we wanted to show there. Okay. So let us move further. And the next one here is that some illustration we need to take on orthogonal circles. First one here is the circles x square plus y square plus 2x plus 2ky plus 6 equal to 0 and x square plus y square plus 2ky plus k equal to 0. They intersect orthogonally, find k. Mind you, please, this is one past JEE question. I wanted to take to make you realize that simple questions appear actually in the final examination. Okay. So let us start from here. As I said, that we will be using that analytic condition for orthogonality for problem solving. So we better use that orthogonality condition here, and for that I will need centers of two circles, C1 and C2. Those two circles, if I have been given, then I can write their respective centers. Centers I am writing as -1 comma minus k and 0 comma minus k. Correct? So one of them would work for minus g1 comma minus f1, and other one would work for minus g2 comma minus f2, and use that analytic condition of orthogonality, and that gives you, what was the condition? Twice of g1 g2 plus f1 f2 equal to c1 plus c2. Substitute there to get 2k square equal to 6 plus k. So this gives you one quadratic equation in k, which on solving will give you minus 3 by 2 and 2. So question was regarding find k. So we have found values of k. Okay. So proceed further to the next question. And the next one is that a variable circle omega cuts the circle x square plus y square minus 2x minus 4y minus 7 equal to 0 orthogonally, and the point minus 2 comma minus 3 lies on omega. Find the equation of the path of the center of omega. Now omega is a circle which meets the given circle orthogonally. So this is given information. So that dotted circle what I have shown, that is omega, which meets the given circle orthogonally, and minus 2 comma minus 3, that point I am naming here as P, is shown on circle omega. Correct? So basically omega is orthogonal to the given circle, and also please use that omega is orthogonal to point circle. What is point circle? X plus 2 whole square plus y plus 3 whole square equal to 0. I am using that point P as point circle, minus 2 comma minus 3. So center of that point circle is minus 2 comma minus 3 and radius is 0. So equation I am taking as x plus 2 whole square plus y plus 3 whole square equal to 0. And circle omega is orthogonal to given circle and this circle. Correct? Since omega is orthogonal to two circles, so C actually lies on where? The radical axis of two circles. Why do I say so? Recall, if omega is actually orthogonal to three circles, then that center was nothing but the radical center of that circle, right? Here two circles are given, so I cannot say radical center. What I should say is it lies somewhere on the radical axis, and that actually gives me that minus 6x minus 10y minus 20 equal to 0. That is the radical axis of those two circles, and hence I say 3x plus 5y plus 10 equal to 0 is the path of center C. Here I end my session. When we meet next time, again something new you will get. Till then, stay tuned. Thank you. Hope you have liked this video. To subscribe, click here, and to place order for the book, click here. Thank you.